Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Morning, everyone.
Morning,
Good
sir.
morning, sir.
How are you today?
I'm good. Thank
Alhamdulillah,
you.
I'm good, thank you,
How
sir.
about you?
When you
I'm fine, thank you. All right, 16 students now. As usual, before we start our lesson, let's pray. Pray begin. Pray finish. All right, guys. Can I check your performance, please? Could you write, please, how many questions you solved last week? I'm expecting that all of you are solving more than 10 questions because last week was the weekly test week. Could you please? All right. Is Ikram here? Ikram? Ikram and Mirza, they are permission, right?
Yes, sir.
Ikram, Mirza, permission. Prayoga, are you here, Prayoga? Could you write?
Yes, sir.
How many questions you solve? And Hambali, are you here, Hambali? Rizky also, could you please write down Muhammad Rizky? Are you here, Muhammad Rizky?
Yes, sir.
Yes, please write how many questions you solve. Yoga also. And Hambali. And I think I couldn't see Hambali here. Hambali in the morning, is he here? Was he here?
In the morning, I think he's not joined too. But in yesterday, he told me if him is run out of quota.
All right. Rizky, Muhammad Rizky. Did you write Rizky? How many questions you solve? Rizky, you didn't study, yeah? Only 5 questions before the weekly? What happened to you? Could you turn on your microphone? Muhammad Rizky.
Yes, sir.
Why only 5 questions you solved last week? Last week was the weekly week.
I only read the materi again,
You read the
and
subject.
then try to remember.
Okay. All right. Did you know your score for the weekly task?
No, Mr.
No.
Of course.
Okay, let me ask some of you. Sauki, how was it? How do you feel about the weekly task?
Sorry, sir. In my connection is a bit.
How do you feel yourself in the weekly task for chemistry?
I'm optimistic if I can pass it.
Was it difficult, this question?
Uh, I think not all of the question is difficult, but uh, just a few of question is I think is little difficult for me.
Right. Denny, how about you, Denny?
Yes, sir.
What was
I'm same with
weekly?
I'm same with Soki, sir. I'm optimistic with my weekend.
Right. How about you, Rizky Ramadhani?
I'm not pretty sure about my score, sir.
All right. How about you, Murshid?
I'm sure enough if I pass it.
All right. Anyone who let's what we say that word? Optimistic to get 100. Raise your hand. You have to be optimist, yeah? No one optimist? All right.
Tawakal, Mr. Tawakal.
Tawakal. How about you, Alfie?
Uh, Tawakal to God. If I get good score, I'm grateful. If I get bad score, ya udah, it's
Oh,
not my lucky. It's not my lucky.
so score is lucky.
Not Mr.
So, okay. I'm going to show you the score. This is just for your reflection today. Today, the reflection is the score. You're going to see the score and you're going to see yourself. And you can compare yourself with the others, with your friend. Okay. This is the score, guys. Congratulations. 3 students from this class get 100. Mirza Baihaki, 100. Rido Gifari, 100. Wisnu Aimariadi, 100. Congratulations for you. You 3 of you get 100. Right. And also some of you got 91. Very good score. Yeah, it's mean there's one wrong. Daud, Andika. Here we have also Murshid, Sauki. Very good. But it is very contrast. Still, some of you got under 50. Ahmad Hambali, 25. I mean, under the 50, only one, two student, Yogi, and also Rofif, now in the 50. And still some of you also under the minimum score, Ali Mubin, all right, Prayoga, Ikrom, Naufal, Muhammad Rizki, you're still under the minimum score. When you see the average, it is 75. It is quite good average for the chemistry lesson. So I think you have to think about yourself. If you get under 75, it's mean that there's problem with you, not with the question, not with the class, because in overall it's 75 and there are students who got 100, not only in this class. Totally, I checked that from 4 classes, there are 7 students, if I'm not mistaken, get 100. So there are many students get 100. And overall, the average is 73, I think, but overall. But this class is 75, which means that this class is a little bit higher than the others. But your class is not the higher. I think your class, the average of your class is the second one. There's also one class with have average higher than your class. But what I want to say here is just for you who get under 75, you have to think yourself. For example, in Ali Mubin, I think you have to solve more equation to get the minimum score. And Yogi, I remind you also, Yogi, last lesson or before last week, if you remember, I told you to solve more question. If you continue only solving 10 question, 11, 13, it's not enough for you, Yogi. You have to solve more than that one. You have to solve 20 question, 30 question. I saw this on your friend here last week solving 50 question. Muhammad Lutfi solving 50 question last week. Okay, as you can see, the score is also good, two wrong. Okay. So when you solve more question, especially for the one who got under 75, I'm sure that you can have a better score later in the final test. Okay, so you still have time to check yourself. We still have 2 weeks before the final test. So check yourself with doing or solving question. If you don't understand the question, you can ask me. You can get an extra lesson from me. So it is important. All right. Okay, that's the reflection for today, because last week it was the last meeting for the rate of the reaction. Actually, we finished the topic. Still, I will do one thing about this rate of the reaction, but I'm going to do it in the non-ficon. There in non-ficon lesson, which is on Thursday. We're going to see some virtual experiments. Actually, it's not virtual experiment. I'm going to show you the video that's showing you the virtual experiments, and from that one, you're going to have an assignment for the score your experimental score. That's about the rate of the reaction. Overall, it's good. Thank you. It's 75. It's a very quite good score for the science. Get that average. Today we are going to continue the last topic, which is about chemical equilibriums. And actually, this topic is for 3-week or 4-week topics, but I'm planning to solve it in 3 weeks actually, but unfortunately we have only 2 weeks, this week and next week. So that's why somehow I need an extra lesson for this. So I'm going to arrange an extra lesson. It can be in this weekend. On Saturday, maybe I'm going to arrange an extra lesson for you. Maybe 1 or 2 lessons we're going to have an extra to finish the topic. So please adjust yourself on the weekend. On Saturday, we're going to have an extra lesson. Okay? It's a compulsory extra lesson, yeah? This is not a normal extra lesson. It's compulsory extra lesson. Everyone must join that extra lesson. Because I'm going to continue the topic that one, and then there will be a question also on the final test about that topic. Okay, anyone to say something about the weekly? No? Right. If there's no, I'm going to share the screen for the next topic. Right. All right, our topic is about chemical equilibrium. In week 1, we're going to learn about that chemical equilibrium, the definition itself, what is chemical equilibrium. Also, I'm going to reach also here in equilibrium constant actually. Also, maybe we're going to start also to learn about that one. Now let's start with this one, chemical equilibrium. What do you understand, or what word that come to your mind when you heard about equilibrium? What word is have similar meanings? Yes, balance. Very good. What else? One student says balance. Any other things? No? All right. Let's see this picture then. What you see in this picture? Any suggestion? Any word or sentence? Sorry,
Reuse or
reuse.
yes, sir.
All right, reuse. Actually, reuse is not like this, but I'm writing here, okay? Reuse is must be three arrow, isn't it, for reuse? Here we have only 2 arrow. Lido say equal. Lido don't like to say something, just like to write. Lido say it is equal. Yes, it is like an equal symbol here, right? Okay, let me write here. Any other?
Reverse, sir.
Very good. Let me read the topic before coming to the classroom. It's obvious. It's a reverse. Yes, in chemistry, this kind of symbol, we can denote it by the words reversible. What does it mean, reversible?
It can be reversed.
It can be reversed, right? Maybe if okay, let me clear this one. All right, so I can check it easily. So we say that it's reversible. Maybe if I put here is the product, here is the reactant. Now maybe it is more clear that in the reaction it can be a reversible. It's mean that one reaction goes from reactant to the product, and also product can back to the reactant or reverse to the reactant. So some of the reaction is reversible. Yes. So this word is important in learning about chemical equilibrium. We're talking about reversible. 2 types of reaction we have in chemistry, reversible and irreversible. The irreversible reaction is something which is cannot go back or cannot reverse to its initial position. For example, explosion, something explode, you cannot make it back to the a situation before it's exploding. Burning also the same. When it's something burning, it's going to be ash, so it will not go back to its previous condition. Decaying is also kind of irreversible process that you cannot go back to its initial position. All right, and the second type of reaction which is related with the equilibrium is called as a reversible reaction. This generally reversible reaction is happening in the industry. Yeah, in our daily life, most of the reaction is look like it's irreversible. If we have a chemical change that you cannot go back, but actually there's some chemical change which is making chemical reaction also can be reversible. For example, this formation of ammonia in the industry, we call it as a Haber-Bosch process, the process to form an ammonia. We know that ammonia is very important chemicals in our daily life for the industry. Actually, this ammonia is formed from the reaction between the hydrogens and nitrogen. Okay, when you react this nitrogen and hydrogen, it will produce NH3, and this process is a reversible process. I mean, this reactant can go to the product, and at the same time also ammonia can decompose into hydrogen and nitrogen in the reverse direction. So this formation is a good example of the reversible process in the reaction. All right. Any question up to here about the reversible reaction and irreversible reaction? No? Okay, all right. You can write this one in your notebook. This slide is important to building up the understanding. Please write in your notebook, please. If still confused, you can ask.
Mister, mau nanya,
Yes, please.
kalau kayak combustion reaction itu masuk ke reversible atau irreversible?
Combustion.
Yeah.
Combustion is irreversible. It's written in the slide. Of course, it is not all of them, yeah. There will be some of the reaction that can be reversible, but mostly the combustion that we understood, that is an irreversible reaction. Finish? All right, let's continue. Aha, what is this? Who wrote this quote? Vishnu, did you write this quote? No? Who is in OSIS in this classroom? Andika, you're in the OSIS, right? Who wrote this, Andika? Is it you? Okay, unknown quote. So the one who write this one, the name is unknown. So that's why it's unknown quote. Or it is Google quotes. I think it's Google quotes because it's very familiar quotes that we use it much in our life. Hidup itu seperti bersepeda. Kalau kamu ingin menjaga keseimbanganmu, kamu harus terus bergerak maju. Did you get something from this quote related to our topic? Yes. When I saw this quote yesterday, I got remember something to our topic, and it's very relevant to explain the equilibrium, isn't it? Which word have a meaning that can be used for equilibrium?
Keseimbangan.
All right, keseimbangan, right? But actually, equilibrium is kesetimbangan in bahasa, but it's all right. It's just kind of different word, but the meaning is almost the same. Keseimbangan, right? This keseimbangan telling you that it is equilibrium because you are using bike. So let me use also bike here. How can you explain the equilibrium or keseimbangan in the various codes by using this bike? Which will hold or keep the balance when you are biking your bicycle?
Speed, I think.
Huh?
Speed.
This,
Uh,
This one, right?
Yes.
What's this we call?
Pedal.
Pedal. Yes, this is pedals. In English also pedals. We have pedals here in bicycle. So what happened in pedal in order to have the equilibrium or the balance, not the equilibrium, let's say the balance when you're biking your bicycle. What happened here in the pedal? Yes,
Rotate.
yes, please. Who's speaking? Murshid, are you?
Yes.
Yes. What do you think?
The pedal is rotating to
Rotating,
keep the
right?
balance. Yes.
All right. What makes something balanced is when the pedal is rotating. Maybe if it's rotating, it's going up and down. But in my eyes, because I'm going to explain you equilibrium, this is not up and down, but it is forward, reverse. You see, the pedal will go forward and the other pedal will go reverse, isn't it? One of them go forward, one of them go reverse. Forward, reverse. They're continuously moving, and the speed of the forward movement to the reverse movement are
Same.
the same, are equal. The speed of the forward movement of the pedal and reverse movement of the pedal or back movement of the pedals are equal, right? So when this process continuing happen, then you will not fall down from the bicycle, right? If you're not doing your bike continuously, then you will fall like the quote. Hidup itu seperti bersepeda. Kalau kamu ingin menjaga keseimbangan, kamu harus terus bergerak, terus bergerak. You have to be continuously moving, isn't it? If you are continuously moving, then you will get balance. Or if in the reaction, if it is continuously moving forward and reverse at the same rate, at the same speed, then it will reach an equilibrium, isn't it? So this is a chemical equilibrium. Chemical equilibrium is a state of balance. As you see, this is a balance in which the rate of forward reaction and the rate of the reverse reaction are equal. It is important. The rate of forward reaction and the rate of reverse reaction are equal. So here, when the pedal go forward and go back or reverse, it must be at the same speed. Bayangkan kalau ini nggak menyatu gitu. Yang satu majunya cepat, yang mundurnya lambat, yang nggak muter bannya, isn't it? But the pedal is designed like this, so when the pedal go forward at the same time at the same speed, the other pedal will go reverse. So the reaction also like that. If the rate of the forward reaction are equal to the rate of reverse reaction, then you will get a chemical equilibrium. And there is another and here. This is that we are going to understand. The concentration of product and reactant remain unchanged. Who can explain this? The concentration of product and reactant remain unchanged. All right, who want to make a stand for this explanation? What does it mean, the sentence? The concentration of product and reactant remain unchanged. All right, Daud, do you want to say something, Daud, about this sentence?
Sisanya itu tidak berubah, masih sama gitu, Mister.
All right. How about you, Andika? Do you understand this word, this sentence, sorry? Concentration of product and reactant remain unchanged. Do you agree with this one? Andika?
Yes, there is no change in concentration of both in product and reactant.
Yes.
I,
You agree with that one?
yes.
How do you explain this?
Uh, I think because the product and reaction is reversible,
Yeah.
so the concentration of product and reaction is apa ya?
Will be constant, right? Yeah, if I'm asking you this question, if the rate of the forward and reverse reaction are not the same, would be the concentration of product rate and reactant unchanged, remain unchanged?
No.
No. Okay, the rate must be equal, right? To make the concentration of product and reactant remain unchanged, isn't it? The rate must be equal. Okay. So there is one proverb that I think easily we can use to understand easily about this concept. Gali lubang tutup lubang. If gali lubang tutup lubang at the same rate, will you have a hole? You dig hole, close it, dig hole, close it, dig hole, close it at the same time, and they continuously happening at the same rate. At the end, do you have a hole? No, nothing changed actually. But you dig a hole actually. You dig a hole, but you close it. You dig hole, close it, dig, close at the same rate. What you see, you will not see the hole. Baru dibuat lubangnya, tutup lagi. Buka, buat lubang, tutup lagi. But you dig the hole, isn't it? You dig the hole and you close it. But it's remain unchanged. So it's something like that. So there is a process there actually. Digging the hole is the process. Closing the hole is also the process. Although you will not see the changing in the hole, you will not see the hole, but there is a process of digging the hole and closing the hole. It is the same like in the equilibrium reaction, guys. In equilibrium reaction, you will not you will not see the changing in the concentration of the product and the reactant. But actually, they are changing. But you cannot see the changing. Yes, they are continuously changing. Yeah, like what we call that recycle. Yeah, they continuously changing. Forward, reverse, forward, reverse, forward, reverse, continuously changing. They are continuously moving. That's why equilibrium is called as a dynamic equilibrium in chemistry. It is not a static equilibrium. Can you differentiate between dynamic and static? I think yes, yeah. You're a grown-up student. You're 11th grade student. You have to know the word of dynamic and static. Static means there's no movement. It is equilibrium. It's balance but no movement. But dynamic, there is movement and also there is a balance. So the movement must be continuously and must be at the same speed to forward and reverse. All right. Okay, you can write this one also in your notebook. Let's do it step by step. Okay, we learn about reversible, first one, and then second one about this chemical equilibrium. Finish? All right, can we move? All right, take a look at this graph. This graph is showing you what?
Rate of reaction between reverse and forward reaction. Rate compress.
All right, this graph is showing you the rate of the reaction. As you can see here, the y-axis of this graph is the rate of the reaction, and the x-axis is time. During the reaction, forward reaction, the rate of forward reaction will decreasing during the reaction. Yeah, here the forward reaction is decreasing. Contrastly, the reverse reaction are increasing. Okay, because it is happening at the same time. As you can see, the time is the same. At the same time, forward reaction will increase the rate. Forward reaction, the rate will be decreased, and reverse reaction, which is the production of product, will be increased. Sorry, not production of product. Forward reaction is production of product. It is decreased, and at the same time, the reverse also happening, and it is increase of the rate. At one point, here we call as an equilibrium point. At one point, the rate are equal. The rate of forward and the rate of reverse will be equal. And after that point, we call as an equilibrium. We're going to see again this one after the break. Yeah, we have under 1 minute now. Let's have a 5-minute break, and then after that, we continue with this. Wisnu menghilang.